There is a moment in science when the data stops being surprising and starts being terrifying, and we are living inside that moment right now. A Nobel Prize-winning physicist, one of the most respected scientific minds alive on this planet, looked at what the James Webb Space Telescope was sending back from the far edge of the observable universe, and he did not celebrate. He did not call a press conference to announce a triumph. He issued a warning. He said the universe we are looking at through this machine does not match the universe we thought we lived in. That the galaxies are wrong. That the structures are wrong. That the physics is wrong. And that if the data is correct, and all evidence says it is, then everything humanity has built its understanding of cosmic reality on for the past 100 years may need to be torn down and rebuilt from scratch. Stay with me for the next 10 minutes, because what the James Webb Telescope has seen in deep space is not just scientifically astonishing. It is the kind of discovery that changes what it means to be a human being living inside this vast, strange, deeply mysterious universe. The Nobel Prize winner at the center of this warning is Adam Rees, a physicist at Johns Hopkins University and one of the most decorated scientists of the 21st century. In 1998, Rees and his team made one of the most staggering discoveries in the history of science. The universe is not just expanding, it is accelerating its expansion, driven by a mysterious invisible force that physicists call dark energy. That discovery won him the Nobel Prize in Physics in 2011. He is not a man who speaks carelessly. He is not prone to exaggeration. So when Adam Rees uses the James Webb Space Telescope, the most powerful instrument ever launched into space, to study how fast the universe is expanding today, and the numbers come back impossible, and he stands before the scientific community and states publicly, with measurement errors ruled out, what's left is the exciting, and daunting, possibility that we've misunderstood the universe. Futura Sciences. You stop. You listen. And then you ask the question that keeps every cosmologist awake at 3 in the morning, if we misunderstood the universe, what is it, actually? What are we really looking at when we peer into that ancient, infinite darkness above us every night? The James Webb Telescope may be showing us the answer, and the answer is stranger than anyone dared to predict. The specific warning Rees issued is about what scientists call the Hubble tension, and understanding it will make the hair on the back of your neck stand up. Here is the problem in plain language. There are two ways to measure how fast the universe is expanding. The first method looks at the very oldest light in the universe, the cosmic microwave background, the faint afterglow of the Big Bang itself, and uses our best cosmological models to calculate the current expansion rate. That method gives a number of around 67 kilometers per second per megaparsec. The second method looks at the universe as it exists right now, measuring pulsating stars, supernovae explosions, galaxies, and calculates the expansion rate directly. That method gives a number around 73. These two numbers should be identical. They are measurements of the same universe using different techniques. But they are not identical. They are stubbornly, persistently, catastrophically different. According to Rees, this discrepancy has now passed 5 sigma, the gold standard in physics for a confirmed discovery, and has grown to 6 or 6.5, growing larger with every improvement in measurement precision. GBH Nobel laureate David Gross described it as a crisis in cosmology. And the James Webb Telescope, rather than resolving this crisis, has confirmed it beyond any possibility of measurement error, deepening the wound in our understanding of reality by proving that Hubble's measurements were correct all along. But the Hubble tension is only the beginning. Because when the James Webb Telescope turned its golden eye toward the very earliest epochs of the universe, the cosmic dawn, the period just a few 100 million years after the Big Bang, it found something that sent genuine shock through the global astronomy community. Scientists expected to find primitive, small, disorganized proto-galaxies. Infant structures barely beginning to coalesce from the primordial fog of hydrogen and helium. What they found instead was extraordinary. Some of JWST's initial images contained enormous numbers of galaxies, far more than astronomers expected, and a good handful of those galaxies appeared to be monstrously massive, up to 100 times heavier than theories had predicted. These were dubbed universe breakers, because they flew in the face of scientists' assumptions about cosmic evolution. Science knew these were not small errors in calculation. These were not rounding mistakes. Galaxies that size, at that stage of cosmic history, are impossible under the standard model. The universe simply had not existed long enough to build them. Most models estimate that a galaxy the size of our Milky Way would not form until roughly 1 to 2 billion years after the Big Bang. Yet in the very first JWST images, astrophysicist Erica Nelson of the University of Colorado noticed enormous, rapidly star-forming red disks appearing in the first few 100 million years. PNAS the universe, it appeared, had grown up far faster than any physics allowed. Something had to be wrong. Either with the telescope, or with everything we thought we knew. Now here is where the discoveries become so strange that even veteran astrophysicists have admitted they were not prepared for them. When scientists began asking what could possibly explain these impossibly bright, impossibly massive early objects, a radical answer emerged from researchers at Colgate University and the University of Texas, an answer that rewrites the very first chapter of cosmic history. New observations from the James Webb Space Telescope hint that the universe's first stars might not have been ordinary fusion-powered suns, but enormous supermassive dark stars powered by dark matter annihilation. Science Daily think about what that means. Every star you have ever seen, our sun, every point of light in the night sky, burns through nuclear fusion, crushing hydrogen atoms together to release energy. But these hypothetical dark stars do not burn that way. Supermassive dark stars are extremely bright, giant, puffy clouds made primarily of hydrogen and helium, supported against gravitational collapse by tiny amounts of self-annihilating dark matter inside them. Futurism dark matter, the invisible substance that makes up 25% of the universe and has never been directly detected, would have been the fuel. And these dark stars would have been extraordinary, growing up to 10 million solar masses, with up to 10 billion solar luminosities PNAS, objects so luminous they could outshine an entire galaxy from a single point. And in October 2025, researchers published spectroscopic confirmation of the first dark star candidates in JWST data, real objects, at redshift 14, just 300 million years after the Big Bang, that matched the dark star profile with stunning precision. The deeper Webb stares, the stranger the universe becomes. Because dark stars are only one entry in a growing catalog of objects that should not exist but clearly do. The James Webb Telescope has revealed a strange early universe filled with ultra-bright, blue monster galaxies, mysterious, little red dots, and black holes that seem far too massive for their age. Science Daily: the blue monsters are ultra-compact, extraordinarily luminous galaxies from the cosmic dawn, so bright that if they are galaxies, they must have converted gas into stars at rates 5 times higher than anything physics currently allows. In August 2025, astronomers at the University of Missouri identified 300 objects that were brighter than they should be, candidate galaxies in the early universe that could force scientists to rethink how galaxies emerged after the Big Bang. Science Daily: then there are the little red dots, compact, deep red objects discovered by Webb in 2022 that appear everywhere in the early universe and then vanish completely after 2 billion years, as if something switched them off. Published in Nature in January 2026, research from the University of Copenhagen confirmed these are young supermassive black holes, and shrouded in cocoons of gas they are consuming to grow larger, the process generating enormous heat that shines through the cocoon, giving the little red dots their unique red color. SciTech Daily: black holes that weigh up to 10 million times the mass of our Sun, glowing through their own feeding frenzy in the infant universe. And on top of all of this, astronomers in early 2025 found a massive galaxy with a perfect spiral structure, similar to our Milky Way, existing within the first 2 billion years, when such delicate order simply should not have had time to form. In January 2026, NASA released something that took the breath away from every physicist who saw it, and it deserves far more attention than it has received. Scientists using data from the James Webb Space Telescope produced one of the most detailed, high-resolution maps of dark matter ever created, peering at a region of sky containing nearly 800,000 galaxies for a total of 255 hours, mapping how invisible dark matter overlaps and intertwines with all the ordinary matter we can see. NASA Jet Propulsion Laboratory Dark Matter, the substance that makes up 27% of the entire universe but emits no light, reflects no light, and has never been directly detected, turns out to be organized in a breathtaking cosmic web. Dense regions of dark matter are connected by lower-density filaments, forming a web-like structure, and ordinary matter, including every galaxy, every star, every planet, traces this same underlying invisible architecture. NASA Jet Propulsion Laboratory. Every galaxy in the universe is sitting inside a dark matter halo. Every cluster of galaxies is threaded through by dark matter filaments. The visible universe, the part we can see and measure and touch, is essentially decoration, a thin layer of luminous matter draped over an enormous, invisible skeleton that we cannot directly observe. And here is the terrifying implication: if the dark matter map does not match our predictions, and Webb is already showing subtle mismatches, then the scaffolding of the entire universe is not what we thought it was. So let us bring all of this together, because individually, each of these discoveries is extraordinary. But together, as a pattern, they point towards something that physicists are now forced to consider seriously, that the universe we are observing through the James Webb Telescope is genuinely different from the universe our models predicted. Not slightly off. Not within acceptable error margins. Fundamentally, structurally, categorically different. Some scientists now hypothesize that unknown forces, unusual physics, or even errors in our knowledge of space-time itself could be involved. The new findings contradict the standard model of cosmology, compelling scientists to rethink established theories on the origin of the universe. Nature. One possibility gaining traction is the cyclical universe model. According to this idea, the Big Bang was not the beginning of everything, but the result of the collision between two previous universes, and the James Webb Telescope could be picking up echoes of that collision, residual gravitational waves, variations in the cosmic background, and anomalous thermal patterns. Nature. Another hypothesis, one proposed by theoretical physicist Nikodem Poplawski and given renewed attention by Webb's data, suggests that our entire universe may exist inside a black hole, and what we call the Big Bang was the formation of that black hole in a parent universe we can never directly observe. These are not fringe theories whispered in the margins of science. They are being discussed openly in peer-reviewed journals, at NASA press conferences, and in the offices of Nobel Prize winners. As Rees himself said, perhaps we are at the beginning of a new chapter in science. The universe is telling us something. We just have to listen, and be willing to challenge everything we thought we knew. Nature. We began tonight with a Nobel Prize winner issuing a warning, and I want to end with something different. Not with fear. With wonder. Because what all of this actually means is that we are alive at the single most extraordinary moment in the history of human science. Every generation before us looked at the night sky and thought they understood it. Ancient people saw gods, medieval scholars saw perfect celestial spheres, and 20th century scientists saw a universe born in a Big Bang and evolving according to clean mathematical laws. And now we have built a machine so powerful that it sees back to the very beginning of time, and the beginning of time is stranger and wilder and more beautiful than any of us imagined. The universe is not finished surprising us. It is not finished teaching us. And the fact that a Nobel Prize winner can look at fresh data and say, we have misunderstood the universe, is not a failure of science, it is science working exactly as it should. Pushing further. Asking harder questions. Refusing to accept comfortable answers when the data says otherwise. If this video ignited something in you, that electric feeling of standing at the edge of what is known and staring into what is not, please share it, like it, and subscribe right now, because every week on this channel